At SOASTA, our focus is on performance analytics. And to us, performance analytics is about more than just solving performance problems, right? It's about solving performance problems in the most efficient way that we possibly can. And I think if we're going to try to find increasing efficiencies in the way we solve those performance problems, it's helpful to look at the tools that we use to analyze and visualize that performance data. And for most people, that analysis and visualization starts with time series charts. And that's for good reason, right? Time series charts are great. They give you context. They give you not just the value of a particular metric that you're interested in, but also the history where that metric has been, and so that you can see not just the value, but also a change in that value. And if that change is troubling to you, then it's a call to action for you to drill in and figure out what's going on and what drove that change. And for most people, that leads to a pivot to another tool, which is the waterfall chart. Waterfall charts may as well be sort of the mascot or the emblem of web performance. If Steve had a tattoo, it would probably have something to do with waterfall charts because they're just so useful. They're so versatile, right? At a glance of a waterfall chart, you can see all types of things that might be wrong with your page. Maybe you've got a front-end single point of failure, or request blocking elsewhere, problems with third parties or first byte time. All sorts of things you can do with that, but I think the problem that happens with us sometimes is we get stuck in using these two tools to solve every type of problem that there is in performance. And so in that sense, it sort of becomes the duct tape and WD-40 of the web performance world, right? It's like if I can't fix it with time series charts, I can fix it with waterfall charts. And what I would like to submit to you today is to consider alternate ways that you can look at data to help you become, again, more efficient in solving those performance problems. And I think one of the biggest gaps that we have today in terms of the way we look at performance is we have a gap in prioritization. What happens is we'll look at time series data trending over time, make this decision that we need to make something faster, and we'll go right to root cause analysis. What's wrong? Give me a list of things to fix on my website. The problem with that is that if you look for things wrong with any website, I guarantee you'll find lots and lots and lots of stuff. In fact, it'll be more stuff than you have time to do. So the question isn't what to fix. The question is, what do I fix first? And in order to do that, you need to prioritize. And I would suggest the way you prioritize it is not looking at what's slowest on your website, but look instead at what users care about the most. Sounds like a subtle difference, but actually there's a big difference between those two things. And that's what this visualization helps us analyze. Okay, so what this does is the x-axis is all the different types of pages on the site. The green dots are the response times, but look at those blue bars. The blue bar, the taller that is, the more the user cares about the performance of that particular page, because that's a key point. Users don't have equal patience across all the pages on the website. So what this is telling us is that while we have lots of different types of pages, there's really three that may or may not actually be the slowest pages, but there's three that people care about the most, and that's what we need to focus our attention on. And it's that, and then moving on to understanding how users move into those pages, right? How do they enter those pages? How do they exit those pages so I can optimize for those entries and exits, make sure my tests are covering everything correctly. And it's only after nailing the prioritization that I would move on to some of the root cause analysis. And so as we consider other tools that we can use to do root cause analysis, I really like tree maps as a visualization for this because it gives me a sense of not only the summary metric, but the scale of the data behind the summary metric. And so basically it reduces my exercise just hunting for big red boxes to go fix. Another one that I know everyone's familiar with, but I just don't think we use enough in the industry are histograms. And a particular application of histograms that we're interested in at SOASTA is with a topic that has come up a lot at Velocity this week, and that's third-party analysis. Bruce Lawson of Opera gave a really great keynote talking about third parties and specifically ads. Yov is working on the content performance policy along with others, and he gave a talk about that yesterday as well. And what we're trying to contribute is to submit ways that you can understand how those third parties are affecting the performance of your site. And it's not just finding a particular third party that hurt a particular experience a particular time, but rather what's making your page slow in aggregate. And also another thing that it's good to look at are things, this is almost like a chord chart. We call it dimension cooccurrence. And what it's about is finding intersections of things. Sometimes the world's not so simple as to say it's a single dimension that's causing the performance problem. It's not just, I'm slow in California. It's I'm slow in California when I'm delivering a particular page from a particular data center. And so finding the intersections of all of those dimensions that conspire to create slow performance is something else that it's helpful to visualize. And using this kind of ring thing where you're intersecting things is a good way to do that. But finally, to bring everything back to full circle, going back to those time series charts and the context, I think there's even a way not just to add tools to our toolbox, but to enhance the tools that we already have. So those time series charts are great. They give you context. They tell you the present value and the past. But what if you could also overlay the future on that time series chart? It turns out there's lots of ways to do that. There's standard deviation, Holt-Winters, things that you can use to build models of what history suggests the future will be for that particular day. And that helps lend additional context so we can make better decisions. And it also helps us enhance perhaps even our alerting. So the alerting isn't just simple thresholds anymore, but they're adaptive, reduces alert fatigue, and makes operation teams more successful. So what I would leave you with is just to, hopefully that gives you some ideas when you get back to work on Monday, things that you could consider to help improve your own analytics. And if you'd like to talk with us about this, we'll be over at booth 420. Thanks, everybody.